Hello and welcome to the CCNP Routing and Switching course offered by Simplilearn. The previous lesson focused on static routing and administrative distance. In this lesson, we will discuss EIGRP. Let us begin with the objectives of the lesson in the next slide. By the end of this lesson, you will be able to explain EIGRP's metrics and administrative distance. Describe how EIGRP's topology and routing table are created, including diffusing update algorithm. Describe and configure automatic and manual summarization. Describe neighbor requirements. Explain the concept of load balancing. Identify the techniques to improve EIGRP convergence and scalability. Let us start our discussion of EIGRP. Enhanced Interior Gateway Routing Protocol, EIGRP, is a proprietary Cisco protocol, which replaced Interior Gateway Routing Protocol, IGRP. It is also an advanced distance vector routing protocol. However, some people call it a hybrid. It does not have a total view of the network as a link state protocol would. However, it maintains more information than RIP. EIGRP does not require a hierarchical addressing scheme, but it works better with it. It is the only routing protocol covered in this course that can support non-IP protocols. Protocol-dependent modules, PDMs, handle Novell IPX, AppleTalk, as well as IP. EIGRP allows route tags. It uses IP Protocol 88 for messaging. It does not use User Datagram Protocol, UDP, or Transmission Control Protocol, TCP. All the routing protocols except the BGP use their own protocol numbers. Convergence occurs very rapidly as a network needs to converge or settle down to normal operations after a change. For example, if a router interface fails, many events occur. The router, along with the neighbor or neighbors on the other side of the link, recognizes that there is a failure. They must recalculate the routes for their routing tables since any routes using that interface will no longer work. These are just some processes that occur after a change in topology. The time taken for these processes to complete is called convergence time. Let us now look at the algorithm to determine the best path. Diffusing update algorithm. All routing protocols use some type of algorithm to determine the best path to each destination. What is considered the best path depends on the metric used as well as the algorithm. The algorithm used in EIGRP is Diffusing Update Algorithm, DUAL, developed by Dijkstra. DUAL is run against the topology database to determine the best path and to rank backups for the path. DUAL finds loop-free routes. The Dual Finite State Machine, FSM, selects the best, least cost path to insert into the routing table. After routers boot and initialize, EIGRP DUAL is rerun only against those portions of the routing domain that are affected by a routing update. That is why it is said EIGRP updates are bounded. Let us look at other router mode commands.